In this clip, we'll use the cosine law to solve for an unknown angle in a triangle. Now, in order to be able to pull this trick off, we need to be given a triangle that has the length of all three sides known. So for example, here's a triangle, and I can see that all three side lengths have been given a measurement. And as long as this is the case, we can use the cosine law to solve for one of these angles. And in this question, it turns out we're being asked to find the measure of angle x, which is right here. So watch carefully how I solve for angle x, because I'll get you to try a problem over here a little later using the same steps. So I think the first thing we should do to keep ourselves organized is label our sides, and that's step one. If you'll notice, angles have a capital letter, and side lengths have a lowercase letter. Since this is angle x, the opposite side we'll call x with a lowercase x. This is angle y, so the opposite side will have a lowercase y. And then z will have a lowercase z. That's step one. It just helps for filling in our values for the cosine law, which we'll do now in step two. In step two, when I write out the cosine law, it's going to look something like this. The way you write out the cosine law is very important for questions. I'm solving for angle x in this question, so I need to have a cos of x at the end of this line. The cosine law says that I need to start off with the matching side length, so I have an x on the left-hand side of the equal sign. And then I use the other two sides, y and z, throughout the equation. And now that I've written out the cosine law, it's just a matter of filling in the values. And in step one, I labeled my diagram, so I can just go ahead and fill in my x, y, and z. I know my x is 9, so we'll have 9 squared, and it's equal to y squared, which is y is 7, plus the z, which is 11 squared, minus 2 times 7 times 11, times the cosine of x. And that angle is what we don't know. That is my unknown. Now that I've filled in my values, I just need to simplify this line a bit and then isolate for this piece at the end, the cos of x, and eventually I'll solve for the angle. 9 squared is 81, and that's equal to 7 squared is 49, and 11 squared is 121. So I'm going to add 49 and 121 to get 170, minus 2 times 7 times 11, which is 154. And that's still multiplying the cos of x. Next, I'm going to bring the 170 to the other side, like this. I'll say 81 minus 170 is equal to negative 154. Don't forget that minus sign in front of that number, times the cos of x. We're getting close to isolating for this piece. I just need to divide both sides by negative 154. So 81 minus 170 divided by negative 154 is equal to the cos of x. Next, I'm going to use my calculator to solve for this piece, but just to save some time, I'll just show you the answer that I got. I just punched it in straight into my calculator, and I got 0.57792 equal to the cosine of x. Now finally, since I'm solving for an angle, I'm going to need to use my inverse cos button on my calculator. So let's do that now. I'll bring in the calculator, and I'm looking for the inverse cos, which is a second function right above the cos button. You remember it has that little negative 1 exponent. So I need to hit Shift, then my cos button. Then I punch in the number I see, 0.57792, and hit Enter. And there is my angle for x, 54.7. We could say, let's just round that to say 55 degrees. Finally, I'm going to say x is equal to 55 degrees. And there's how you use the cosine law to solve for a missing angle. So just remember, as long as you've got a triangle where you know the length of 3 sides, you can use the steps I showed you to solve for the unknown angle. Now, are you ready for some practice? Try using the steps I showed you to find the measure of angle A for this triangle, and I'll post the solution when you're ready. Angle A is 54 degrees. We found that by labeling our sides first, A, B, and C, and then filling in the cosine law, remembering that we are looking for angle A, so it goes at the end, so we need its matching side, A, on the left-hand side of the equal sign. Then we just fill in the known values and isolate for cos of A by moving this piece to the other side and dividing by negative 1,850. Finally, we enter this into our calculator to get 0.5914, and then we use our inverse cos button, and we find A is equal to 54 degrees.